Welcome back to part 2. Sorry about the short cutoff there. Anyway, we're talking about butter. So 80% fat, 16% water. The 4% is usually the remaining proteins and sugar that's in there. It gives that butter a nice sweetness. And you can add other things. You can salt it. You can whip it up and increase the amount of air that's in there. You can add other things, flavorants. Butter is wonderful. Okay? Now talking about cooking with butter, right? Well, butter's got a few really wonderful characteristics to it. The main one being that usually when we harvest fat and we use fat to cook with, we're getting a pure fat. That is to say, it is only olive oil is exclusively the oil part of that olive. It's exclusively the fats. Whereas butter has all of these different compounds in it, which give it an extra flavor complexity that's just unmatched in the culinary world. Specifically, a lot of people say it's very nutty, right? And what this does, and gives a great, and is wonderful to cook with, is that butter contains both carbohydrates and proteins. And as you learned last time, when you undergo a browning reaction, that is to say you start to cook the carbohydrates, and there's protein around, instead of just undergoing regular browning, we're going to get the Maillard reaction. So when you use butter, say for example on your toast, and you brown that butter, you're actually getting the Maillard reaction, which again, it gives you that extra meatiness to the foods that you're cooking. Whereas if you just had toast, there's lots of carbs there, there's no proteins, so you can't get that Maillard reaction, which is one of the reasons butter is wonderful from a culinary perspective. The other thing you can do with it is if you melt it and essentially get out all of the milk solid, or the butter solids is what it's called, so the extra protein and sugar. Usually this is done by melting it and then taking off the layer of just plain fat, or filtering out all the little burned things that accumulate at the bottom. You get what is called clarified butter. Now, clarified butter is one of the most magnificent substances in all of culinarydom, and as far as I'm concerned. Not only does it have a really high smoke point of around 450 degrees Fahrenheit, which is comparable to the best of oils, so you can fry anything you want in here, but because the fats in it are mammal in nature, they're animal derived, they definitely have an extra meatiness to them because they started out as saturated fats. They are saturated fats, which definitely just adds a new complexity to your foods. And that's just a takeaway lesson for this whole course is, take something you normally know how to do, and if you can change it just a little bit, usually the results are simply delectable. So the last thing I want to talk about is margarine. Same thing that we had with milk. Everybody loved milk, but they couldn't get enough of it. So Pasteur and homogenization came around and they fixed that. Well, butter is a lot harder to produce. You don't get nearly as much butter per amount of milk. So the problem wasn't getting the butter to the people. It was producing enough. So mid-1800s again, we have Napoleon Bonaparte. And he says, I want something that I can give to my people that is like butter, but easier to produce. So, again, a French culinary scientist comes along and says, well, maybe I've got all this animal fat, like cow tallow lying around, and I wonder if I just mixed it with some extra milk, like some skim milk from the butter I made earlier, if that would, and then process it like butter, if it would give me something like butter. Turns out, yeah, it does. And so we get margarine. Now, all margarine is an artificial butter, so to speak. Nowadays, it's mainly produced from different vegetable oils, which undergo a process to take their saturated or their unsaturated fats, which again, remember, unsaturated fats just mean it's got this extra kink in it, and turn them into our saturated fats. Now, early on, the process of doing this through the process of bombarding this with electrons, and what that would do is artificially turn this into a trans fat. That was discovered very early on. And now we know that trans fats aren't so good for you. But good news, that's not the only way to turn our unsaturated fats into saturated fats again. So fear not, as long as you don't see trans fat, it's still pretty good for you. As good as butter can be. And in fact, nowadays margarine is actually far more consumed in America than actual butter, which some might say is a bit of a culinary tragedy, because butter is just this unique, pure, unreplicatable thing. But margarine does get pretty darn close. It's a lot cheaper. So, what did we learn today? Well, we talked about the components of butter, of milk being lactose. We've got our proteins, casein and whey, or curds and whey, and we've got our sugar, lactose, and our fats in globules that give it that distinctive creaminess. We talked about pasteurization, heating it up for a little bit to kill those bacteria. Homogenization, breaking up the fat to make it less separatable. Concentrating the milk to make it last longer. We also talked about turning it into cream, which is letting it separate and taking that top part of the cream or of the milk, and the uses of that in foams as well as in high temperature cooking. And then if you even process cream even more, you can get luscious butter, which is beautiful because it can undergo the Maillard reaction, but it can also be replicated pretty good facsimile as margarine. So your lab this week will be in the bonus bit. If you have any questions, as always, please let us know. Thanks for watching, guys.